I'm Jim Anderton, and this is the Industry Insights and Trends podcast. On this show, we'll explore the length and breadth of 21st century engineering, from civil engineering mega projects to innovation at the quantum level. We speak with subject matter experts and industry watchers from every sector of the engineering discipline. I'm with Dr. Tonya Custis. She's Senior Director of AI Research at Autodesk, and we're here at Autodesk University 2025 in beautiful Nashville, and it is a big, powerful, fascinating event. And Dr. Custis, welcome to the podcast.
Thanks, Jim. It's nice to be here.
It's Autodesk University, Autodesk 2025. Tell us, what are we doing here in Nashville?
What are we doing? It is a large user conference for Autodesk, right? It's about 11,000 people, and from all of the industries we serve. So media and entertainment, architecture, engineering, construction, and also manufacturing and products. So it's a lot of people. It's also more casual users, right? Like makers, and it kind of runs the whole gamut.
Yeah, and that's one of the most fascinating things I think about this conference is engineering professionals, of course, are used to conferences about the tools used for engineering in here. This space is occupied by sculptors and artists and architects and just tinkerers and people that are doing interesting things. That's radically different. Does that affect the way you do your job?
Yes and no. I think so. For my job, we do research in my team. So we're doing AI research. So research to sort of further the state of the art of AI, and then in ways that overlap with Autodesk users. So in some ways, it makes my job a lot easier because Autodesk users are such a wide group of people.
Now, you're an expert in AI, and it's the hot button issue of the year, of the decade, probably, and maybe the hot button issue of the first couple decades of the century, if we really think about it. Everyone's talking about it. Tell us, maybe we could frame the discussion a little bit to begin with. When we talk about agentic AI, what is agentic AI?
Agentic AI really just means an AI agent, let's say, is an agent trained to do a certain task. Okay, so that itself, not super interesting. When agentic AI gets interesting, I think as people are talking about it more and more now, is when one AI agent can call other AI agents or use an MCP server, Model Context Protocol, to call lots of things. So you maybe call up some data, call up different tools that aren't AI, but then also to call other AI tools. And that's really where it starts to get interesting, right? You have one AI agent talking to another AI agent, and there's a real multiplicative power there. But I think it also speaks to the ability to build flexible workflows. So I would say one of the issues in design and make generally is that everyone's workflow is so different. And for us as a software company, right, that's very hard to anticipate everybody's workflow. So what's happening with agentic AI is those workflows can be sort of built on the fly, right? And so that makes it really powerful.
Now, we also hear a lot about generative AI. Tell me, what can you define generative AI for us?
Absolutely. So that's what my team does. We do generative 3D AI. And so what that is it's AI that's trained on a lot of data to then generate things. So things like ChatGPT, right, is a generative text model. You've also probably seen a lot of generative image models, right? And so those are one-dimensional in language or two-dimensional with images. And so what we are doing is we are building 3D CAD generative AI models.
Now, generative design, of course, has been talked about for some time, even before the recent buzz in AI. And conventionally, we think of design as something which is a big iteration machine, something which is essentially going to simulate at the speed of computers and do what 1,000 engineers might do over 10 years to sort of whittle every last atom of weight out of your design. Will Gen AI approach design problems like that the same way?
No. In fact, they're actually very complementary to each other. So generative design is very powerful, but it is a brute force sort of, and to your point, at the speed of computers. So actually, it's gotten a lot better because computers have gotten so much faster, right? But it is a brute force approach that is, using topological optimization to give you all of the possible answers. But generative AI, on the other hand, is data-driven, trained from data, so it will give you probabilistic generations. So in that case, right, it will take in sort of either whatever kind of prompt you have. So the systems we're building, you can put in a text prompt or a sketch prompt or even a geometric prompt, which I would say is like a partial design that you then want to autocomplete. You can think of it like that. And so it's different, right? So it's not generating all of the possibilities. It's generating what are the most relevant possibilities given the context you gave it, right? So it's a little more interactive. It's also not deterministic. So generative design is generating everything, so it's very deterministic. Generative AI is going to give you a different answer every time. And also it's so much easier to use, right? So I think one of the problems with generative design is that you have to know all the constraints ahead of time. You know, it's really, really hard to get it set up. Once you get it set up, it's great. With generative AI, you can just say, like, I would like an air fryer, and it will generate one for you.
Yeah. It's in the AI, from the AI context, is the difference in AI the way it approaches the problem as much, or the way that it has access to an almost infinite amount of data to work with? That it can look outside the box in a way. You mentioned example of the air fryer. If you're designing the air fryer, of course, you're already automatically constrained in your own mind as an engineer about things like materials, shapes, masses, sizes, production techniques, and you would not think of looking at something that was done 50 years ago experimentally in a lab somewhere that's in an Elsevier paper that no one has seen for decades. But AI can see everything everywhere all the time. So is it a matter of it being quote unquote intelligent, or simply just so well informed?
I would say so well informed, right? I mean, AI is really only as good as the data it's trained on. And so, you know, there are definitely trade-offs there, right? But yeah, it's the models you're seeing with text and images, they were trained on the whole internet. Like, that's a lot of data. So it really is about the scale of data, but also, you know, and that works for 1 dimension and 2 dimensions. For 3 dimensions, there isn't a whole internet of data. So we really do need to balance it with also improving the AI science to make those models work well. But yeah, it really is, it's a well-informed system, and it's also doing more systems thinking, right? When you do generative design and you fill in, I don't know, 20, 30 parameters, you're doing the systems thinking, right? As a professional, and that's great, but it's arduous, it's difficult. And if you want to change one thing, wow, you got to run the whole thing over. It's a lot of work. With generative AI, it's doing the systems thinking for you, right? And it's more flexible. It can sort of take prompts. Like it might not do what you want at first. I'm sure you've probably tried like an image generator and been like, no, that's not what I want. But you know, you can edit it. You can go through and do it again, right? And what we're doing with our 3D models, they're generating editable 3D CAD models, right? So even if you don't like it, right, you can edit it. And the goal is that, you know, that initial generation saves you time and you can go back and fix what you like, right?
Yeah. Now, the IP question always comes up whenever I talk to any industrial users specifically, and some would love the idea of an AI-assisted designer that would take my bracket, for example, look at it, and then compare it to the design of millions of brackets done by everyone else in the space, including my competitors or people at the other side of the world. On the other hand, we're quite proprietary about this information. Do we necessarily want the AI looking at what we do and using that as a reference frame with which they can then optimize and leverage my competitor's product there? How does AI fit into that world?
It's a very complicated world for sure, especially in the industries that Autodesk serves, right? So very often our customers do not own the IP of what they're designing, right? Especially in media entertainment, but certainly architecture and engineering as well. So it is a complicated sort of chain of custody issue for data, but it's also the case that the way the models learn, it breaks the data up into very small geometric primitives, right? And it sort of throws them all into a big mass of things, right? And it does a lot of counting on them, right? And they're all aggregated. So it's very unlikely that once your design is broken down into like lines, edges, vertices, faces, that is going to hold any more IP at that point, right? And so things that are very rare in the training set are just thrown out, right? So So bracket is a good example, though, of something that's not rare in the training set, right? So there's probably, millions of brackets. And so you also don't want to get too creative in generating a bracket, right? Or say like a catalog item, like a bolt or something, right? You don't want to be like, look, our system made a brand new kind of bolt. Great. So it's very situationally dependent, but it's also based on frequency. It's based on, the fact that geometry is so broken down. So with language models, it basically does this at the word and the letter level, right? So an isolated word is not in trillions and trillions of words, right? It doesn't hold any real information other than that word identity, right? So it's a really complicated problem, but it really is about that balance of stripping all the data down to the point where we can learn from it. So we're learning geometry. That's what we're learning. We're learning 3D CAD geometry. We're not learning styles. We're not learning, proprietary designs that only one company designs, right? Because those would get thrown out. So it's science. I will say that, right? My team are AI research scientists. This is science. We, verifiable metrics. We measure everything. Performance is measured. But we also then can measure that we don't show anything that was in the training data, right? So we're not showing your design to competitors.
Yeah. It's a related issue. Many manufacturers of industrial products, electric motors come to mind, a big industry, huge industry. One in which motors are generally made to specific classes or classifications, and engineers tend to specify from a catalog list. Mm-hmm. And you find the one which is rated for the kind of duty that you anticipate, with a little safety factor, of course, built in. The holy grail of electric motor manufacturer, of course, is built to look at one customer to say that cooling fan in that bakery oven in that food plant, I want to be able to wind you a custom motor which is exactly optimized for your application, for lowest cost, maximum durability, lowest energy costs, low maintenance, all of that. That's theoretic. That's realistically impossible, because you'd have literally millions of different electric motors in your product line. However, when we say that's impossible, one wonders in an AI-run food company, mm-hmm. in which all the parameters are constantly watched and monitored of the electric motors as they are now, or the demands on their system. In the future, could we see that information fed back to an AI-enabled system electric motor manufacturer who says, not only can I do a custom motor just for you and just for your one machine, we can deliver it at about the same time frame and cost we could a stock product?
Yeah, I think that probably comes down to like components and interoperability and things like that, right? But absolutely, and I think that's something that we're really interested in here at Autodesk, is not just design and make, but what is the product life cycle? How can we, digital twins, right? Like, how do you monitor the performance of the product as after you've designed it, after you've made it, right? And how do you then feed that information back in to improve it later?
Yeah. And does that data have a value? Or is a future where, if you're General Motors, is there some value, some IP price you could put on the data they generate internally?
Possibly, yeah. I would say at this point, all data has a value. Data is the fuel for AI. So it's the competitive differentiator, right? If you look at different companies, say like, different search engine companies, right? Like, everyone uses this one and nobody uses this one. Like, the algorithms for the one everyone uses are probably not as good as the other algorithms, but they have more data, right? So it all comes down to data. And, it's, I think that we'll see actually a lot more commoditization of data, sort of in the way that you're describing.
Yeah. Now, there's no way to talk to an AI expert, let alone a leading AI expert, without bringing this subject up, because it's the elephant in the room, which is what will we all do for a living? In the engineering space, we're looking at engineers, and to be honest, I was young when AutoCAD came out, but the immediate horror ran through the drafting department. Every draftsperson in there thought, we're done. Engineers will literally make their own renderings now. They don't need us anymore. And in fact, what happened is those draftspeople ended up training up into the AutoCAD seats, and they actually ended up with a higher value, better paying, more satisfying job. Will the same thing happen with AI?
I think we'll see a lot of that same thing, definitely. I think different shifts. There'll be new jobs that come out of AI as well. So, and like you said, it happens with every new technology. I think, AI captures people's imaginations a little bit more, so maybe it seems scarier. But no, there's always going to be new jobs. There's always going to be people kind of getting upskilled, and also it's going to give people more time to do the creative parts of their job that they like. Like, I don't think anyone who is an engineer or designer wants to spend all their time moving this line over there or making it longer, right? I mean, they don't want to. They want to do the fun stuff, right?
Live from Autodesk University 2025, Dr. Tonya Custis, Senior Director of AI Research with Autodesk. Dr. Custis, thanks for joining me on the podcast.
Thanks so much. Glad to be here.
That's it for today's Industry Insights and Trends podcast, brought to you by engineering.com. If you like this program and want to keep pace with the latest innovations in engineering, subscribe to our newsletters such as Design Weekly, 3D printing, aerospace and defense, digital transformation, simulation, or a weekly roundup at engineering.com/subscribe. For our deeper engineering series, visit engineering.com TV for exclusive shows like Designing the Future, Manufacturing the Future, and the Engineering Roundtable, found exclusively on engineering.com TV. Thanks for tuning in.